All right, let's talk our way through 2.4, number 28, more or less. So one, they do tell us that this is a homogeneous or homogeneous or however the heck you say that word, nonlinear equation. You guys all believe that this is nonlinear?
Yes.
How can you tell?
It wouldn't be continuous at x and y equals 0.
Let's see.
It would have an asymptote.
It would be discontinuous at x equals y.
Yeah, so it would be discontinuous on a whole function, x equals y. That's a fair concern. Another thing I might just read into it is like, okay, so if I multiply this x minus y to the other side to try to make it fit into the linear form, I'm gonna have a y times a y prime. I'm not going to be able to get rid of that in any kind of probably convenient way because I've got an x on this side. So in kind of moving that back and forth, I'm going to see that I'm kind of running into problems. Honestly, on this, I'd probably say something like you can tell because of the way it is, which is not really fair, but is also true. All right, so this is homogeneous nonlinear, right? First order homogeneous nonlinear ODE. So, and keep in mind, this homogeneous nonlinear is like essentially all one word. This is a very specific type of equation. And what is the technique that goes with this type of equation?
Substitute u equals y over x.
Okay, so if we shove u equals y over x in here, let's see, that'll tell me that y is ux, right? Which would tell me that y prime is what?
You end up with u prime x plus u.
Okay. And you can memorize this if you want. Personally, I prefer to just make this substitution every time. It should be noted that this isn't really in a homogeneous nonlinear form like right off the bat. I wouldn't have guessed that this. I mean, I guess I would have. I would have guessed that this was homogeneous nonlinear, but I wouldn't have immediately known that without making the kind of check for this, right? The check for this is that you have y prime as a function of y over x. Right, so you'd have to actually kind of dig through this thing for a minute to find that if you didn't believe this already. They told me it was, so I'm just going to do this. All right, so I'm going to stuff my y and my y prime in here. So my y prime is going to give me u prime x plus u equals x plus ux over x minus ux. So my differential equation becomes that. You guys all with me? Okay, so now what?
You can factor an x out of top and bottom and they cancel.
Okay, so you might just notice that this thing is x times 1 plus u over x times 1 minus u.
Correct.
Seems legit. Okay. So now I've got u prime x plus u is, I've got 1 plus u over 1 minus u. Okay. Now, what's my goal here? What am I trying to do?
Trying to get u prime and u on the same side and x on the other side.
Yeah, so the homogeneous nonlinear thing is once you make this substitution, it should be separable.
Yeah.
So my hope is that I'm going to be able to separate this thing. So I just need to kind of walk through that algebra. And again, this is one of those problems where the path's not necessarily incredibly clear. You just like keep doing stuff till it happens. It's in here. Right? If it's homogeneous nonlinear, and you make this substitution, it is separable. This will work, but you might have to persist a little bit. So we're going to maybe subtract u to the other side. So I got u prime x is 1 plus u over 1 minus u maybe? Okay, now what?
Multiply the minus u times 1 minus u over 1 minus u.
Okay, basically jam everything over the top of a common bottom here. Okay, so that was subtract u and get a common bottom to your fractions.
And factor it all and get 1 plus u squared over 1 minus u.
Okay, so maybe do a little collection on the top. So I got 1 plus u minus plus u squared all over top of 1 minus u. Oops, and that was a u prime x is equal to that. That was just a little classic FOIL action or distributor, whatever the hell kids call that these days. Then we maybe notice some stuff cancels. Okay, so now I need to get this back to the other side, right? Because I'm supposed to get the x on the right and the u's on the left. So I'm going to get a 1 minus u over 1 plus u squared. U prime is 1 over x. So that's multiplied by 1 over x and 1 minus u over 1 plus u squared. Basically, flip both sides over, right? Okay, now on.
Integrals.
Yep, slap some squiggles on there, get your dx to the other side. So you should be integrating 1 minus u over 1 plus u squared du. And on the other side, we might just notice that's natural log of the absolute value of x plus constant. Okay, so am I caught up to where you were at, Bridget?
Yep, yeah. That's where I ended up, and then I did a integration by parts.
On the, well, obviously in the integral, I suppose.
Yeah, on the left side, yeah.
On the left, or did you do that to the thing you didn't have to integrate? That was dumb, my bad. All right, so yeah, you kind of look at this thing on the left and you think to yourself, well, how the heck do I integrate that? And you might think to yourself, oh, well, let's see. If it was 1 minus u times 1 over 1 plus u squared, I might differentiate the 1 minus u and integrate the 1 over 1 plus u squared. That would work. It probably gives you something that's algebraically equivalent if you do it right. I personally would look at this and see that as the integral of 1 over 1 plus u squared minus u over 1 plus u squared.
Oh, okay. That's a lot easier.
Yeah, this is one of those things, though, like, if you don't see the easy way, then it's going to be kind of a pain in the ass. And if you do see the easy way, it's really pretty easy. I don't know. I don't feel bad for not seeing these all the time. I miss them sometimes, too. Like, I'm sure if you go back and watch all the videos in the differential equations class, you'll find me stumbling over these things occasionally, because it happens. Certainly before the end of the course, you will see me pick the wrong way to do something at least one time. And it happens. Don't feel bad about it. Just know when to quit. Okay, so do you want to try the integration by parts way just to see what terror looks like?
If you want to. Your way definitely seems simpler. I ended up like with a weird kind of mishmash, but yeah, we can. I chose to do A and B instead of U and V, so I already had a U. So I ended up with A is 1 minus U, and then dB was 1 over 1 plus U squared du.
Okay, I'm down with that. And so then so B then should be the integral of this thing.
Yeah, and you end up with it.
So that should be arctangent of u.
Yeah.
And when you differentiate a, you get minus du.
Yep.
Okay, so then I'm really just integrating this piece, by the way. So then that should be the product of this and that. So 1 minus u times the arctangent of u. So that would be normally my uv, right? And then I need minus the integral of v du. So I need to minus integrate minus arctangent of u du.
Right.
And then this is probably where things get real nasty because I don't know the integral of arctangent off the top of my head.
Yeah, I had to look that one up. It was minus 1/2 ln of the inside. So I ended up with minus 1/2 ln of 1 plus u squared.
Oh, okay. So let's see. Wait,
Is that right?
I don't know. Hang on. Let me show you how I deal with frustration. I can't be bothered to own a calculus textbook. Okay, so I need
Oh, maybe I missed the first term.
I need this part. Okay, so let me kind of force that to fit my situation here.
I see what I did wrong. It would have canceled if I had the first half of the second integral, because I ended up with an extra tan in there that would have canceled out. I ended up with an extra arctan.
Oh, I got you. So this piece got lost somewhere?
Mm-hmm.
Gotcha.
Okay.
Yeah, so in this case, right, I'm not talking about x's, I'm talking about u's. And so I should have 1 minus u arctangent of u plus u arctangent of u minus 1/2 the log of u squared plus 1. And I guess I've assumed that by log they mean natural log.
Yeah.
I'm pretty sure that's true from my memories of Wolfram, but let's see. How would I know for sure?
You could do 1 over x.
Good.
Well, if I did it on my n spire, it gave me natural log, so that's what I went with.
Yep. Should be noted, in Wolfram is based on Wolfram's based on MATLAB, the piece of software, and MATLAB is math software, not accounting software. So by logarithm, they mean the math logarithm. If they want an accounting logarithm, they'll write log 10, as opposed to what everybody else in the world does.
What's the difference?
It's so natural log of 10 is like 2 point some garbage, and log 10 of 10 is 1.
Oh, yeah. But okay.
So the difference between the two functions in terms of calculus land is just that one of them kicks a constant when you differentiate or integrate it, and the other one doesn't. Right? Like one's the inverse of the natural exponential function, and the other one is the inverse of the 10 exponential function.
Yeah, but why would people? Well, I guess what's the difference? Like, I don't know how to phrase it. Never mind.
Why would they do this?
Well, like
I think it's easier to model like economic and business like functions based off of a 10 power rather than some irrational number. Is that correct?
It's really just easier to take 10 logs of things that show up in money.
my main what I was asking is what does Wolfram Alpha do different?
Oh, well, when Wolfram writes log,
Yeah.
what they mean is natural log.
Okay, that's just kind of more annoying, but
Yeah, whereas when other people write log, what they mean is the 10 log, the base 10 logarithm.
yeah, that's how I was taught.
Yeah, and that's the yeah, that is the convention everywhere except in applied mathematics sometimes. It is something to be careful of as an engineer because a lot of engineers use kind of robust computer programs to do math. And a lot of robust computer programs that were designed to do math are based on the like deep thoughts of applied mathematicians. So this does happen in engineering software. If you want to know, just when you start, calculate log of 10. And if it's 1, then you're operating with a base 10 logarithm. And if it's 2 point something, then they mean the natural log and you just rock it.
That doesn't make sense. I mean, ln is even easier to write than log.
I know. I'm not a fan. It goes.
Hey Joe, quick question about the math here. So after you integrated by parts, you have 1 minus u in parentheses time arctangent, but then the parentheses are gone, and I'm not really sure what happened there. Because the parentheses mean you can't cancel out that other u arctangent.
Oh, sorry. That was just crappy notation on my part. You're right. I was just talking while I multiplied and screwed it up. All right. So I got my stuff, and I've now straightened out that Wolfram means here a natural log. Okay, and this stuff is all supposed to be the natural log of x plus a constant. And then I might just notice that some stuff cancels. So this arctangent cancels. And so now I've got arctangent of u, that's that thing, and minus 1/2 the log of this guy, that's that thing. Cool. And then here, let's see, they wanted me to solve a differential equation, right? Have I done that? So here's what I got at the end. I got arctangent of u minus 1/2 natural log of u squared plus 1 equals natural log of the absolute value of x plus constant. Oops, and I guess if I was doing a really good job, I would be, this thing would be blue because it came from up there. Oops, that's not helpful. And this whole thing would be blue because reasons. Okay, so once I finish my digression through either integration by parts or integrating the pieces, I should end up here. Now, have I answered the question that I was asked?
Sub your y back in, your y over x.
My what now?
Your y over x. Y equals ux, yeah.
Yeah, you weren't asked a question about u's, right? There weren't any u's in the original equation, so this doesn't mean anything, right? And this happens. This happens more and more as we get further and further into this class. You'll have made several substitutions and you'll have answered a very relevant question. But it's not the answer to the question you were asked. It's an answer to a sub-question that you posed yourself. So in this case, right, I made this substitution. Now I know what u is. So in order to find what y was, I need to make that back substitution. So u was y over x. So I should end up with the arctangent of y over x minus 1/2 the natural log of y over x squared plus 1 equal to the natural log of the absolute value of x plus a constant.
I feel like this might be a dumb question. Isn't arctangent y over x just an angle?
Yeah.
So then how exactly are we simplifying the arctan y over x?
Oh, I'm not. It is an angle, but it depends on y and x. So it is implicitly a function of both y and x. I could get rid of this part by taking the tangent of both sides of the equation after moving my log term to the other side. But that's probably a real shit idea. Because, like, oh yeah, sure, that'll get me y over x, and then I'll have the tangent of a difference of logarithms and a constant, which is not really a place I want to be in, you know? So you can shove this around algebraically a little bit, but I don't think it's going to get any better here.
Hey Joe, I just noticed you have last parentheses on your left side, but you don't have anything on the other side to
I have a
close it.
last parentheses on my
Yeah, on past 1, the +1.
this one.
You don't have another one to cancel it out on the other side. I don't know where it ends. Oh, you have that little kind of oddly shaped one there. Okay, I see. I didn't see that.
No worries. My handwriting on a whiteboard is okay, not great. On this thing, it's worse, and yeah, it gets worse when I'm talking, and it gets worse when I'm writing fast. And I think I was doing all three things there. So,
By the way, this was the problem I was talking about, where if you graph it on GeoGebra, it looks like garbage.
oh yeah, but Desmos does a much better job.
Yeah.
Yeah, that is maybe that's a relevant statement here. GeoGebra has a lot of trouble graphing implicit functions. So in this case, at least, Desmos does a better job graphing this.
Also, it's insane that the book even offers you the explicit form of this function.
Wait, the book offers you the explicit form of this function?
Yeah.
How do they even get it?
I have no idea. I think so, because I remember having to graph it because I couldn't find the explicit form.
The thing I'm seeing in the manual is
This is 28.
this is what the solutions manual has,
Maybe I was looking at a different one.
which is somewhat simplified. You guys see how this got a little bit more simplified? Looks like something changed here.
It's almost like a 3D function.
It is a 3D function. Yeah, this is level curves of a function of x and y. If you want to fiddle, like if you want to get from this stuff to that stuff, a little log ruling will get you there. It's gonna take a hot sec.
Oh no, yeah.
But you can do it. The 1/2. So bring this thing to the other side. You slap a -2/2 in front of it. Then you suck part of it in here as a division. You find a common bottom in here. Like it's all there, but that's gonna spend a second. I would, yeah, check. Those are equal. They are. It is a bit of a dig to get between the two. Any other questions on this problem?
That clears it up for me. Thank you.
Okay.